those ideas and builds upon it. In Redux, we have actions. There's very similar to Flux actions. Actions are just payloads of information used to send data from the application to the store. Actions are just plain objects that can be logged, serialized, stored, and later replayed for debugging or testing. Actions must have a type property. That's the only rule. This type property is usually defined as a string constant. The model update logic lives in one part of the application, a distinct layer. In Flux, those are stores, but in Redux, those are reducers. The only way to change state is to bit an action, an object describing what happened. This ensures that neither the views nor the network callbacks will ever write directly to the state. Instead, they express an intent. Flux has been described as state action results in a new state. Redux is basically the same. Reducers are just pure functions that take an action and the state and return the next state. One difference between Flux and Redux is that Redux does not have the concept of a dispatcher because the store is taken over the dispatching. Redux relies on pure functions instead of event emitters. Redux uses functional composition, whereas Flux uses callback registration. Pure functions are easy to compose and easier to reason about because they don't rely on an external entity to manage them. Additionally, Flux makes it easier to reuse your stored logic in other entities and areas of your application. In Flux, stores are generally flat, but in Redux, reducers can be nested via functional composition. Redux assumes that you will never mutate your data. The state isn't manipulated directly. Each slice is copied by the reducers, and then all the slices are combined into a new state object. So let's go over some of the core concepts. I really like Lynn Clark's code cartoons. If you haven't seen them before, you should check out her fun and quirky explanations of concepts in React. First, we have here the action creators. The action creators format a payload of data in a way that the rest of the application can understand. Redux action creators don't send the actions to the dispatcher. Instead, they just return a plain object. And then there's the concept of a store. In Redux, there's a single state tree, whereas in Flux, you have multiple stores that each control their little piece of the state. It's like their own little world. Redux stores tend to delegate more because there's a dispatcher that the store is taken over by delegating to the reducers. And those reducers do the work on each little slice of their state tree. The reducers are where the real work happens in Redux. When the store needs to know what an action needs to do to change the state, it asks the reducers. The root reducer takes charge and slices up the state based on the object's keys. It passes each slice of state to the reducer that knows how to handle it. Each slice is copied, manipulated, and then all the slices are, again, as we said, combined into a new state in the root reducer. Oh, sorry. I mentioned 2 slides. I apologize if you guys missed that one. So last fall, a couple of us were assigned to a client. It was supposed to be a short project at West Interactive. For various reasons, given the timing, it's between kind of Angular 1 and 2, and they wanted to be able to support IE8. We decided that we would build this new project in React. We'd learned some of the concepts, we'd taken a workshop, but none of us had really used this in real life in the world. We didn't really know what we were doing. So we set out on a quest to figure it out. We saw what seemed like a lot of debate on where to put asynchronous calls in Flux. We really felt like we should go with Facebook's recommendations on this, so we chose Flux and kind of went with those patterns that we saw there. But we were still wondering, should the API calls be made in the components, in the actions, in the stores? Like, where does this belong? Most of the examples that definitely shouldn't be making API calls in the store, right? We did some research and we decided to go with a solid example by Dan Abramoff. Maybe you're familiar with some of his work. So then we dove in head first. We wrote these action creators that made asynchronous calls to the API and then sent that off to the dispatcher, who then handled the promise and then used these corresponding success and failure action types to dispatch additional actions as a result of that promise. And then we used Dan's example of an asynchronous handler in the dispatcher that would handle the promise, dispatch either the success or failure action with the corresponding response. So if you didn't recognize that previous pattern, I'm sure that some of this Flux boilerplate is familiar to you, and hopefully you're able to read that code from in the back there. So basically here, we're listening for changes, emitting updates, registering the callback with their dispatcher. And then we had our components able to call our action creators, and component did mount and load the asynchronous data for changes to update the component state. So we have this all figured out. Good enough. We're off to the races. So things started to grow and scale. We added another developer to the team. More API calls need to be made to fill out the data. With Flux, the actions seem to be fairly limited to a person interacting with the application, like through a web API call or maybe through updates from the server via WebSockets. However, you might want to fetch some data independently of user actions. For example, like refetching your most popular content or refetching stale data once in a while. You may also want to fetch in response to a route change. So it's never really wise to couple fetching to some particular UI event early on. As development continued, we ran into some pitfalls. Namely, this one. If you've worked with Flux for any amount of time, you probably recognize this. Cannot dispatch in the middle of dispatch. When we added this other developer to the team, she was tasked with creating components nested in other components that needed to provide views into sub-resources of the data that we were already working with. So she started working down in that level, right? Well, what she found was that she wasn't able to call the action creators to load the sub-resource data because there was already an asynchronous action running from the outer components component in mount that had not finished yet. So we started seeing a lot of this. We came up with some workarounds, as every good developer does, just keep chugging along. So this workaround that we came up with at least allowed her to call a series of asynchronous actions in the outermost container and then pass the data down through the props to the lower containers. We wrapped our mid-change events in a set timeout. We all know that set timeout is usually a hack that makes big Jesus cry, right? Right? We stopped short of grabbing the dispatcher in timeout too. We really thought we could get a handle on this. So, according to Bill Fisher, a software engineer at Facebook that you might be familiar with, he works on React and Flux. He said, as the set timeout hack, that's a hack that should be avoided. Dispatch within a dispatch are caused by improper code design 99.9% of the time. Instead of doing the set timeout, do what you need to do in response to the original action. I think this is most often a reflection of equating actions with setters. They are not listening. Okay, well, fine then. Sorry, I keep reading the switchable slides. Alright, so another issue that we ran into was the error swallowing. We were having some issues with data not really showing up, and we never saw any errors in our console, and we were just kind of wondering, why and what's going on here. But then we figured out why. So the dispatcher that's provided by Facebook anytime an action is dispatched to it. Simple enough, right? However, one problem that we ran into is that it will eat any exception that occurs in the callback. Presumably, this is because it wants to keep, one failing callback should not cause your whole application to blow up. So what we decided to do was follow a tried and true method from a blog post that we found. We decided that we would monkey patch the dispatcher with this modify method to get errors to appear in our console again. It was a little helpful. So basically, we defined a function that would return and log any errors of the function that is passed. And then we overrode the dispatcher method, the register method of the dispatcher to use modify. It was okay. We found with Flux that the best pattern to use had us closely coupling our actions to the full set of data that a given view needed to display. It wasn't ideal, but the dispatcher didn't complain anymore. In this example here, we had to queue up a couple of API calls and then handle the secondary response here in our API handler so that we could pass that off to the dispatch handler who was only accepting a single response object. And then we just thought, well, we better name these API calls very specific to the data that they're returning so we don't lose track of where all this is coming from, right? Didn't really help us keep things sorted out. So we started looking into Redux. As we were looking at Redux, the idea of middleware seemed like a godsend. The essence of Redux middleware is that it runs in the store before the action is dispatched to the reducer. Middleware allows us to chain processing so that things such as logging, crash reporting, talking to an asynchronous API, routing, timeout handling, almost anything you can think of, allows us to chain that together through the processing. It provides a third-party extension between dispatching an action and the moment that it reaches the reducer. So one of our favorite middlewares is Redux Thump. Remember how actions in Redux and Flux are supposed to be plain objects? With Redux Thump, not really anymore. You can do whatever you want. So Thump is a subroutine that is created to assist a call to another subroutine. Functional programming languages allow us to generate thumps by wrapping an argument expression in an anonymous function, which prevents the expression from being evaluated until a receiving function calls the anonymous function. Not bad, right? Redux Thump middleware allows you to write action creators that return a function. This is what you need to know. This function accepts a dispatch callback argument instead of a plain object, and then the thump can then be used to delay the dispatch of an action or dispatch only if a certain condition is met. We're using ES6 arrow functions for currying to provide better readability into this function cascading. Currying is the technique of translating the evaluation of a function that takes multiple arguments into evaluating a sequence of functions that each take a single argument. The really nice thing about this pattern, for me anyway, is I'm not a functional programming expert by any means, and so that once you have it going, I don't really have to think about it anymore. I'm just thinking about the API call that I need to make and the result that I want from it. At least that's how, my brain works more effectively when I abstract those complexities away. Another middleware that we really like is the Redux logger. Not only does it log your state changes with your actions, but it also shows you any error that occurs. And it includes stack traces! Stack traces, you guys, of course. I mean, what else would you want to debug here? So you want to know that when using the Redux logger with apply middleware in your create store, that the logger must be the last middleware in your chain. Otherwise, you'll end up logging the thump, not the actual actions. With Redux middleware, it feels like you really can have it all. As far as the specific things that we've been struggling with in our Flux application, we have some decisions sense. We could, keep our actions as is because Flux and Redux actions are basically the same thing. We have the option of actually kicking off multiple asynchronous actions in the component did mount. Or we could always dispatch another action as a result of an initial action. And we ended up using a mix of all of these things where they made the most sense. If you recall, previously we were limited to fetching this data with a single action to show a given view. Redux allows the flexibility to untangle that dependency. We can get what we need in the container's component did mount, and then if an inner container needs more data, we can supplement that too. Now we're doing some real work. You'll see here that we're using our action creators to make calls in the component did mount. And then we are supplying our data as props via the selectors on the reducer. So remember that the Flux dispatcher doesn't allow you to dispatch in the middle of the dispatch. When we wanted to be able to refresh the store from the API, like say after making an update, and then we run the full data set again, we ended up making an API call in the store. This really circumvents the action, dispatch, store, data flow. And this is bad. It should really feel bad. This doesn't allow other stores to know that there is a request for data and that they should process it. So the reducers in Redux, as we said, are where the real work happens. Reducers are composed of pure functions. Pure functions rely on only what is explicitly passed to them as arguments to produce a result. That is the most basic definition. The function always evaluates the same result value given the same argument values. Pure functions do not rely on global or other state. The function result value may not change or depend on any hidden information that may change as the program execution proceeds or through different executions of the program. So it cannot call any non-pure functions, such as math random or date math. Nor should it depend on any external input from I/O devices or API calls. No API calls in the store. Evaluation of the result of a pure function does also not cause any semantically observable side effects or output, such as mutation of mutable objects, routing transitions, or output to I/O devices. These changes should all happen before an action is dispatched. When using Redux, it's a really good idea to try to flatten out your state tree as much as possible so that you don't really have to go so deep to make modifications to your state. There are several options for helping you ensure that you do not mutate the state. One of those is the object assign. It lets you assign properties of several objects onto the target object, but you'll want to be aware that the target object is mutated, so most often you'll be supplying an empty object as your first parameter to object assign. The use of spreading is also very common, and that's what we're showing here in this reducer. ES6 gives us not only array spreading, but also there is the proposed object spreading, which is available to you if you enable it in Babel. We use spread to copy own enumerable properties from a provided object onto a newly created object. And then also you have immutable.js. With immutable.js properties of object maps, for example, the properties are hidden behind a get set interface, so you're not able to access them directly or modify them. Similarly, with an immutable step, you can only modify it with push or pop. Whatever method you choose, now there's one thing you learned today, that you are not allowed to mutate your state. This is one of the three main principles of Redux. The three being that the state is read-only, there's a single source of truth, and changes are made with pure functions. delegate out to each other. You'll use a combined reducers utility available from Redux that assigns slices of the state to specific reducers. And then you have selectors, which prepare the data in a way that you are expecting to display it. Your state shape should be encapsulated in the file in which it is contained. So here we have like an all IDs reducer and a by ID reducer. The by ID reducer is a way for us to conveniently access each item by its ID. And then the all IDs reducer allows us to then transform all of our objects into an array in the way that the UI is expecting to receive it. So with your existing React project, hopefully you've already done a good job of separating presentational and container components. Does everybody know what those are? Excellent. So you want to use connect and define a special function called map state to props that tells you how to transform the current Redux store state into the props that you want to pass into a presentational component that you're wrapping. In addition to reading the state, container components can dispatch actions. So you can define a function called map dispatch to props that receives the dispatch method and returns callback props that you want to inject into the presentational component. These examples I've shown here, however, utilize the Redux thumb to receive the dispatch method. So here we're just passing the action creators directly into connect. It's a good shortcut. All container components will need access to the Redux store so they can subscribe to it. You'll use the special React-redux provider component in order to make that store available to all of your container components without actually having to pass it down through the tree of components. You only need to use it once. This is when you render the root component. In this case, our root component is the router. So what about your existing dependencies on Flux? Well, the official migration documentation says to rewrite Flux stores as reducers and create a function called create Flux store that creates a Flux store compatible with your existing app from a reducer function. I chose to tackle the migration by cordoning off a section of data and components that have the least reliance on other pieces of data in our application and then work out from there. So for the most part, we were using our Flux actions with Redux. So then I was able, in our Redux action creators, to just go ahead and dispatch those actions with the same responses and payloads. And then our Flux stores just pick those up, and our existing components are able to use these all unchanged. You might also notice here that we're changing the route in the success handler. When using the plain React router, so Redux really is not aware of our router state. So what's next in our migration? We would really like to be using the react-redux router. Routes are technically another part of the UI state. The react-redux router allows us to link that state to Redux. We'd really like to be putting more of our UI state into Redux, and one option that we found we really like is using Redux form. Not being able to access controlled component state outside of the component can be very limiting at times. For example, we're using this form validation library, but we are not able to access the validation state of the individual form components from the outer form until a submit is actually occurring by the user. It's kind of a pain. So really bringing that UI state into Redux will also have the added benefits such as logging, global undo, time travel debugging, and many more. That's really all that I have this evening. I want to thank GoHealth for hosting us this evening. I really want to thank Object Partners for sponsoring this talk. Finest Pizza, we're really sorry. We thought that the pizza guys had recommended that we should get this many pizzas, and apparently we've run out. But, you know, we've decided that we're going to buy you all drinks of your cake. We'll make it up to you, I promise. As an extra special thank you, I would like to personally invite you